Editing dialogue scenes could very well be a thing of the past soon. Anyone who has ever edited a dialogue scene knows how time-consuming and boring they can be. Researchers at Stanford University have developed software that uses AI to help edit dialogue-driven scenes. The editing software is built upon the concepts of editing idioms. The paper they published defines idioms as rules of thumb for conveying a narrative through editing decisions. For example, ensuring that the speaker of each line of dialogue is visible, intensifying emotion by using close-ups for emotional lines, etc. The software works by taking in a few inputs: the script, the footage, and the desired idioms. The system breaks down the script into lines of dialogue and organizes the clips by each line. The user pieces idiom blocks together, like a puzzle, or similar to block programming languages like Scratch. This very simple to use interface is very fast and easy to use, which significantly cuts down the editing time of dialogue sequences. Of course, this program is not perfect, but could very well prove to be a very useful tool for editors. Here's a comparison of the scene edited by a professional editor and the program.
Stacy.
He's a bad kid.
He's family.
Are you sure that your cousin is his real father? Because I'm pretty sure that kid is the spawn of Satan.
Come on now, that's a bit dramatic.
Oh, really?
Yeah.
You're gonna make me regret saying that, aren't you?
I am not buying that kid a Christmas present.
Stacy.
He's a bad kid.
He's family.
Are you sure your cousin is his real father? Because I'm pretty sure he's the spawn of Satan.
Come on now, that's a bit dramatic.
Oh, really?
Yeah.
The program works in two phases: the pre-processing phase and the editing phase. In the first phase, the program segments and labels the footage according to structural data it receives from the inputs. When segmenting, the program time-aligns the text dialogue in the script with the audio from the video. This is done with the help of Rubin et al.'s phoneme mapping algorithm, which, from what I understand, uses a neural network to convert text to phonemes. Using this information, the program can then align the takes to the lines of dialogue using something called Levenshtein's edit distance, which uses words as tokens. After this, the program begins to label the inputs. Here are the script labels. Speaker. The script is labeled by the name of who is speaking. This works by using the assumption that the script is formatted according to the AMPAS screenplay formatting standard. Emotional sentiment. Using the NLTK sentiment analysis algorithm, the program is able to detect the emotional intensity of each line. Using the open face algorithm, the program is able to track the face and compute the following labels using the tracking information: shot type, zoom. The main subject's face is identified, and then using scikit-learn's k-nearest neighbor classifier on the zoom factor, the shot is classified as one of 7 of Bowen zoom categories. Speakers visible. The mouth movement and the speaker in the script is used to compute this label. Clip volume. The average root mean square, or RMS energy, of the audio signal is used to determine the volume of the speaker in each clip. Clip length. This is the duration of the clip. In the editing phase, an HMM model is used to model the editing process. The program then uses some very sophisticated equations and functions that I don't understand to come up with the best edit according to the defined idioms. If you want to see more of the software in action, I've linked a video of the paper in the description. I've also linked the paper itself. If you also want to see some more examples of software being used to help humans edit, I've linked some more examples below. My name is Adrian Trejo, and this has been my oral presentation on computational video editing for dialogue-driven scenes.